Alright, so just going to do a quick video on how to repair a DragonFly32 micro. It's pretty much the same hardware as a Naze32, and the problem is when you plug in the USB, nothing happens. I can show that really quick, but it's got the STM32 103 CBT6, and I also believe it has the MPU 6050 and a barometer on it. So I'm going to go over to the screen. I'll show you what it does when I plug it into the computer. So I'm going to grab my USB cable, micro USB. So I'm going to plug it in.
Alright, from here you can clearly tell I accidentally unplugged my webcam, so I'm going to narrate this over the audio that was lost. So I'm going back here to the scope. When I plugged it in, I realized the voltage regulator on the board was getting extremely hot, which indicates possibly a short to ground or a bad voltage regulator. So the first thing I'm going to do is I'm going to take the board and just do a visual check over it. I don't know what's been done to this, what kind of abuse it's had, so I just want to kind of look for myself, see if anything is visibly wrong with it. So I'm starting from the top here, zooming in to get a better view. Here's the barometer right here. I believe it's the same one that might be on the Naze, can't remember. Just looking at all the SMT components, looking at the USB pins, make sure they're okay. They're a little bit off to the left, but I don't see any solder bridges. So everything looked good on that end. Flipping back to the back, the main portion of the chips on here. Looking at the voltage regulator, it looks good. There's a little bit of some like hot glue or something stuck to the top. No big deal. The crystal is a little bit off, but still not bad. Here I'm pointing out a big indicator. It's a little blowhole on the top of this STM32 chip, and that usually indicates like the magic smoke escaped, that there was a short inside and just killed some connections and made it blow that little hole. So what I'm going to do is I'm going to turn on my multimeter and put it into continuity mode, because I want to check for direct shorts to ground to get an indication of what might be going on with this. Again, when I plugged it in, there was no COM port came up and no lights or anything. So that's just usually a key indicator that something with the main logic chip is wrong. So I'm going to do that right now. My probes can measure this while recording it at the same time. So the pins here, the one on the right should be VDD, if I believe, and the one right next to it is VSS, or also known as ground. And you can look at the data sheet for these to actually get the pin out for what they are on the chip, since you don't actually have the schematic for the board. So I'm doing that right here. I'm testing continuity between ground and VDD, and you can't hear it, but I'm getting 0.6 ohms on the multimeter, which indicates that I do indeed have a short to ground. So something is wrong with the power delivery on this, and since I saw that blowhole on the STM32, I don't feel comfortable with leaving that on there, so I am going to remove it and replace it with a new one from the factory. I got the part from DigiKey. I could probably leave a part number just down in the description. If people think it's at all helpful, you can just easily search the STM32F103 CBT6 and you'll get the hit at their site. It's about like $6 to $7 in low quantity, so not a big deal. So right here, I put it in the clamp holder so I don't melt anything under it, because I just have an ESD pad that doesn't like heat. So I'll apply a little bit of flux on each side of the chip to help the heat disperse and also kind of clean things up on the chip. So that's just what I'm doing here. Flux works really nice in spreading the heat and actually helping everything flow so you can get it off. I gotta get better about focusing as well. That's something I'll work on in future videos. So right about here is when I noticed that my webcam came unplugged. So I have a second clip when I plug it back in and get things going again, and we'll switch to that right now.
Okay, I'm back. So I got it clamped, I got the heat gun on, so let's do this. I don't know why that wasn't working earlier. Get what you pay for. So I'm just using an actual cheapy heat gun. It does the business. It's a 303D from SparkFun. Are we recording? Yep. Okay. Alright. So I should have had this on. Now what I'm going to do now is just clean up the area, get rid of all that lead-free solder, and replace it with some nice leaded. So I'm just going to use solder and my soldering iron to do that. I don't want to create any solder bridges. You don't want to have your heat too high, otherwise you might pull off traces as well. So that's never good. Looks good. So some nice fresh solder. Let's get some more flux on there. Let's get our new chip. Same one. Might try and leave a part number in the description if anyone's interested. You can just easily search up on DigiKey. That's who I typically go through. So remember the orientation last time. You can tell by the dot. You'll see here in a second. See the dot in the upper left? That designates pin 1 over there. So keep that in mind. You don't have to get this exactly straight, but you want to at least get them over their pins. Then we'll heat it up here again in a second. It should flow right in. And while this is heating up, one thing I could have checked and should have was that after I removed this chip, to do a continuity test again just to verify that the short is actually gone, because it may have taken out other components, like the regulator, for instance. But usually the regulators are pretty good with their thermal throttling. And so it's starting to get up to temperature here. I'm just going to help it. You can see the solder getting pulled in. Once all of them melt, it should self-align here. And you can see it, move it. So I'm just going to push down and make sure there's a good contact between the chip and all the pads, until I see some of them start to dry and actually hold it in place. So since it's a small board, it'll take a little while for the heat to actually dissipate. So you see that one in the upper left just cooled down. So I think that's probably good. So we'll go in there and check all the pads. It's still really hot, so I gotta be careful. So yeah, it's still super hot. So let's check most of them. Hopefully that's in focus over there. It looks like it's in focus for you guys. So all of our pads look pretty good. I'm happy with that. Make sure I didn't create any solder bridges. I think this was supposed to be like that. All components are still there. Looks good to me. So, it's still pretty hot. We're going to test it here in a second. You don't want to plug it in while it's too hot, because a lot of the time with the regulator having that thermal regulating, it'll actually decrease the voltage, so it'll appear like it isn't working when it actually is fixed. So feels pretty cool now. So we're going to go back over to the screen and let's check this out, see what we get. Put my headphones on. Alright, so I am plugging it in now. Removing the dog hair from my USB connector. Let's see what we get. Plugging it in. Okay, so I have a blue light now, which is good. This chip, by default, it has no bootloader. It's just fresh from the factory. But as you can see, you see it? I have a blue light. So I'm going to go ahead and try proceeding with flashing. There should be some boot pads on one of these sides. Oh yeah, very small to flash it. So it might be in the bootloader mode right now. So I'm just going to go ahead and do it. I usually flash these with the Naze32 firmware. See what we get. So okay, no response from the bootloader. Okay, so I'm going to go back over to the microscope. And I'm going to short out those bootloader pins over here. I believe that's it right there. So let's do business. Come on, heat up. Those guys are so tiny. Okay, that's not working like I like. So let's take this on the jumper wire. So it can just, I don't like, that's super small, otherwise I would use tweezers. So I'm just going to use jumper wire, do this for me. Why those boot pins are so small. Good enough. Get out of the way. Let's go back to the computer, plug it in. Blue light again. Got a COM port. Let's get on the screen. We got a COM port. So this is still up, so we're just going to try and flash the firmware. Again, if you look at the top, I have no reboot sequence, full chip erase, and manual baud rate, latest Naze firmware, because it's the same hardware. Flashing the firmware. So it's working. So good. We're not done yet, though. We have to test it. After this is done, we'll remove the short wire I put on there. And hopefully whatever shorted out didn't take out the gyro, accelerometer, and barometer. Sometimes you see that, but let's see what happens. Cool, program successful. We got a blinking green light. So let's unplug it, remove the wire, and then test it. So I'm gonna go back to the scope. This is the easy part. Okay, wire removed. So it should no longer be in the bootloader mode. We're gonna go back over, left screen, and try it out. Let's plug it in. So I got flashing light, green is blinking green. Got a COM port, cool. So let's go try and connect to it. Awesome. And so can move it. Everything on the board looks good. We see barometer, accelerometer, and gyro, so everything looks great. No data flash because we have no flash chip. Awesome. Looks great. So I'm trying to start a series of these videos. I'm repairing a bunch of RC equipment. I know a lot of people out there break stuff, and I don't want people to get discouraged about how easy it is to troubleshoot and repair these. I'd like to see people just start repairing them. I know they can cost, $20, $30, but when the chip itself costs $6, to me, I'd rather just try and repair it than buy a new one. And it's good because you learn something, and I'm all about learning something new. And the biggest difficulty with all of this hardware out that's nowadays is you don't have a schematic for any of it. So you kind of have to use your head a little bit and see what goes to what, where the voltage regulation is, where the data connection paths to the motors, how the accelerometer and gyro connect into the chip. Just various troubleshooting methods you can do, looking at signals to see if the USB to UART controller is shorted and out. I've had some to where it'll actually show up a COM port, but no matter what you do, you can't get into the bootloader. And that was a fault of my own. I had actually shorted the transmit and receive pins, which I actually took out that section of the chip. So even though I was getting COM ports, it was very misleading that that chip was good. Sometimes you get lucky and you get things heating up, and you're easily able to find out what is the hot part, what's shorted out. But in this case, you could clearly see the blowhole on that thing, and it's replaced. And if you don't see any voltage at all or anything getting hot, that's usually a good sign that it's the voltage regulator. But other than that, I hope you learned something, and hopefully look forward to more of these videos. Cool. Thanks, guys.